Right?
Okay, thank you, Ray, for the introduction. Can you see my slides?
Yes.
Okay, wonderful. My name is Z Zhe. I have spent more than 10 years building graph databases, right? RDF, right, and property graph. So I love both graph data models equally. So today I'm going to talk about towards better query understanding. I'm going to introduce a particular application, right? Unit of measurement. So first of all, some key team members, right? I have been collaborating with structured data team and search. Me, myself, I'm from eBay search. I'm going to start with a problem statement and introduce some baseline implementation of unit of measurement, UOM. Okay, focuses on a KG-based approach. Finally, I'm going to summarize. Well, this is a one screenshot of eBay search page. The query is a 1 foot cable, right? This is the query part. If you run this query on eBay website, you will see quite reasonable results. However, if you switch your focus to a particular category, say comics, right, then you start to notice there's quite a few irrelevant items. So it's clear that search doesn't always understand a query, including numbers and units. Okay, this is the motivating customer problem. So what is UOM? Everybody here understands what a UOM is. It's a definitive magnitude of a quantity defined and adopted by convention or by law, right? So there are two important parts. One is quantity, the other is unit. On the right-hand side, I have listed a few sort of, typical units, right? Like mass, length, temperature, time, luminous, intensity, etc. Okay, so this gives you a sort of the background of what kind of unit of measurement we care about. Well, I'm part of the query understanding team in eBay search organization. At query understanding, we care about 3 different levels of understanding. Let's work our way bottom up. At the lowest level, we take a look at the query, right? We try to study the tokens and phrases and bigrams, trigrams, etc. Right? At this level, we gain shallow semantic understanding of a query. Now, one level up, after we extract entities, right? UOM is a particular entity. We gain moderate semantic understanding. The level we do want to achieve is deep semantic understanding. Here, not only we extract and understand the entities, but we also discover the relationships among the entities. Unit of measurement, UOM, actually span across all these 3 layers. A few observations about UOM. Maybe some of them are specific to e-commerce. First of all, UOM data is of high value in e-commerce, right? If people are selling something, or if a buyer is trying to look for something, right? If the query or if the item title contains, say, 32 GB or 5 inches, right, or 10 pounds, etc., those data are really valuable because they carry really good semantics. UOM queries, right? A query containing UOM, say 32 GB or 5 foot, right, 6 inches, whatnot. Those queries tend to have lower recall set size than average. Okay, and at eBay, UOM exists in both item data. It's a listing, thinking about a particular iPhone, right, and also structured data describing that item. So here, structured data can be sort of as key value pairs. Color red, right, is one piece of structured data, right? So storage capacity equal to 128 terabytes, right, is another kind of, key value pair. We care about queries containing UOM because those queries tend to have a higher purchase intent, right? Just to give you a concrete example, if people are looking for, hey, iPhone 10, right? This is one query. Another query is, space gray iPhone 10 with, 512 gigabytes. If you think about these two queries, the latter one definitely has a higher purchase intent. Okay. However, queries containing UOM are more tail-ish. So they don't show up that frequent compared to more, headish queries. So in general, right, queries containing UOM tend to have less behavior data, less user logs. Okay. So first of, baseline implementation uses. This is quite intuitive way. One can look at UOMs and say, hey, I can use regular expressions, right? The challenges with regex-based UOM rules, they're kind of hard to maintain. Just to give you a one example here, right? If you think about to measure length, right, you should need a number at the beginning followed by inches or meters, whatnot, right? So one would quite intuitively write, a number, a regex followed by IN. However, we have this 3-in-1 fast USB charging cable. Right? 3 IN, if you apply a regex, right, it looks like just 3 inches, right? And this kind of approach are much harder to extend to other entities, right? People, places, events, timelines, whatnot. Now let's focus on a KG-based approach. I'm going to describe a high-level flow. As you know, eBay is a marketplace, right? That's more than 1 billion items. So here, you're seeing a listing flow, right? Item data are coming in from the sellers, from selling APIs. The box in the middle captures the key logic, right? We use NER, it's a deep learning based NER model. We use character level encoding. And then the output, right, is those entities and segments fit into a knowledge service. This knowledge service will identify and canonicalize the units. So as you can see here, we identify 10 inches and corresponding units in meter. Okay? And then those information are stored on items. Now, at query time, the query comes in, query may or may not contain a unit of measurement. We pass the query through the same service endpoint, which does NER and knowledge service. And then we are able to extract, if there's any, UOM URIs that exist in the query. If we put these two workflows together, right? Item data flow in, we extract UOM URIs, query comes in, we do the same thing, and then we match them up, right? If there's a match, that information can be used to increase recall and also improve ranking. A specific example here, given an item at the bottom left, Lenovo is a model number S27i-10 27-inch monitor. This item comes in through this workflow. We are able to extract 27 inches and the corresponding amount of meters for this item. Query is the box on top is Lenovo 27 double quote monitor. We all know 27 double quote means 27 inches. So this query flows through the same pipeline when we are able to extract 27 inches and corresponding meters. So if there's a match, this can be used to increase relevant recall and also BM25. It's a one improved version of TF-IDF. Now let's look at the KG service, this particular component in the middle. Bottom up, there's a graph construction. We are leveraging Wikidata graph and there's some other public data sources. We then build a graph database. We expose lookup APIs, Sparkle query APIs and search APIs. And these APIs are able to identify a span, okay, a sequence of tokens. And the output can support a variety range of applications. Search query understanding is one of them. Okay, so this is sort of the high-level architecture of the knowledge service. On the left is a snippet of the knowledge graph, right? It shows the definition of inches, degree of Celsius. What I want to point out is this is just a tiny subgraph, right? We are also interested in products, brands, material, and whatnot. Wikidata itself has a lot of information, a lot of definition and relationships, right? For this particular application, we extract a subgraph, essentially units related subgraph out of that. On the left, you see a particular Sparkle query. We use recursion, right, to pull out all the sub-concepts of unit of measurement. So this is sort of our baseline. Now, to give you a concrete idea how we are doing the resolution, right, for a piece of text, so this can come from a query or come from an item title, right? 36-inch hardwood table. The NER is able to identify dimension, right? The beginning of a dimension is 36, the end of the dimension is INCH. It's also able to identify material, etc. Okay, so this dimension is actually critical because it sets the context. Okay, you may wonder why INCH is ambiguous, right? Actually, if you click on the links here, you will see there's a band. Band's name is inch. There's a location. There's a town's name is called inch. So that's why this context is crucial. Okay. By using this context and all those actual tokens, we're able to map this piece of 36-inch to a node in the knowledge graph. So a few examples here, right? The leftmost column in the table shows the raw text. Okay? And the third column shows the regex-based UOM logic. Right? In this particular case, for 2-foot strobe cable, the regex approach is able to identify 2 feet. But the knowledge graph-based approach is able to further canonicalize that. Okay? The second example, 3-inch cable, right? Regular expression, it's a 3-inch, 3-in-1 fast USB charging cable, right? Regex actually has a false positive. And okay, and knowledge graph does not recognize any UM, which is the correct thing. So overall, we see a quite significant precision improvement when we apply knowledge graph. It's more than 10% for queries and item titles and structured data in general. Okay. This is, when we are handling UOMs, right, at listing flow, right? We take the data, we identify entities, we extract UOM, and then we resolve those UOMs, right, against the KG, and then we canonicalize it. Okay, the data in green color is the output, right? We can identify volt, hertz, gigabits per second, length, weight, you name it. Okay. Now let me skip this. So let me talk about the query flow, right? At query time, we decompose query into parts with layered semantics, right? With token level and at KS entity level. In a way, we consider those URIs as the synonyms, okay, to the original tokens, and we use that to drive better recall and better ranking. a few lessons, details matter, right? We notice that sometimes, user may put in a fraction and also a decimal number side by side. Okay, we didn't notice that, but later on we found out that that's a small challenge. And it's always a good idea to start from a small graph. Okay, one good thing is units are not very language specific. So the NER we built for English seems to be working well for German and other different languages. To sum it up, unit of measure UOM plays an important role in e-commerce search. And eBay is learning how to use and build a KG, right, to empower search, to make search better. In the future, we plan to extend entities beyond UOM, right? The high-level goal is to really achieve better query understanding. Okay. Thank you.
All right.
Any questions?
Thanks, Joe. Any questions?
Just a comment. I wish we had this when I was at eBay, because we suffered so much with units of measure when we deployed the first MT system.
Yeah, it sounds like a small problem.
Big
but
problem.
To get it right, it's quite a challenge.
Yes.
Because there's so many ways to write all those in numbers, right? Sometimes people use double quote, sometimes they use IN, sometimes use INCH, sometimes use the plural form, sometimes use two single quote, sometimes use two apostrophe, right? The variety amazes me.
Yes. That's what I most remember from eBay, is the variety of the input. That's a nice way of phrasing it.
Right.
Yeah.
Congratulations on the project. Just congratulations on your progress. It sounds great.
Yep. Thank you, Mike.
I just wanted to sort of add something here. Not really a question, but this was one of the motivations for us to build Retail Graph at Walmart too. Unit of measure. It's a huge problem, and when you categorize your queries as head, tail, torso, these are all in the tail, but these are the ones that can potentially give you a lot of conversion.
Definitely, yeah. So people typing the UOM in the queries tend to have a much higher purchase intent.
Yeah,
they know what they want, basically.
Exactly.
Okay. Joe, I have a quick question.
Yes.
So if the query, if in the query the unit of measure is not the standard unit, so for instance, most monitors are 27 inches. So if somebody put in 28, so how would you match with the listings? Match with 27 inch?
Great question. That's something we are considering. Essentially, it's kind of fuzzy or range matching, right? Currently, we don't do that. We only do that at a high level, right? We can, if the TV is say 35.6 inches, right? We put a range on that item, okay? And then if people are querying for say 40 inches, it may match that because 40 is, at the boundary of that particular range. But if people are trying to query a small number right close to that value, we don't do that because this has to be contextualized. In one category, TV, off by a half inch is not a problem. But in some scientific devices, right, definitely you don't have that luxury. So this kind of fuzzy or range-based matching has to be contextualized. That's something we are working on.
Okay, so that contextualized, is that something you learned or something you just manually defined?
Another great question. I think we probably have to take a hybrid approach, right? We have to seed it, right? Have some initial understanding of different verticals, different categories, saying that, hey, in this vertical, it's okay to loosen up a little bit. Say comfort shoes, right? If the size is off by half size, nobody cares. But if we are talking about rock climbing, you better make sure the shoes fit perfectly, right?
That's true. Okay.
And over time, we have to learn that from the user behavior.
Cool. Yeah. Thanks for sharing.
One of the things that we had learned at Walmart to solve the same problem, right, is by looking at the product category, and depends on whether you want to go how deep you want to go in that hierarchy. But let's say TVs, right? So if you just take LED TVs, and we would actually look at the lower bound and upper bound for attributes. So the context that you were mentioning, so we would just take that context, which is basically an attribute, either the screen size or dimension, and then look at the min value and max value for it and put that in the kg. That way we know, okay, this range, because there could be people typically put multiple numbers, and then you want to know whether they're describing the height of a product or width of a product. So this is where the range actually came in handy for us. So we used to capture range and fill that from the product attributes. We would fill that back into the knowledge graph as a range. And then our NER models would actually use that to map it back.
Okay, that sounds like a good idea. Yeah.
Xiang, you have been very quiet today so far. Quick question. So in academia, is there any research in this domain, the fuzzy match?
Yeah, I think there's a few technical problems in this pipeline. Like segmentation by itself is a very challenging problem already, especially when you go into different domains. I mean, like I think in commercial search, there's new vocabularies and framing things coming up. So I don't see any tool will be stable to any emerging data. So I think segmentation, I found by myself, I found it very challenging, especially for this queries type of data. And then disambiguation and finding synonyms. I actually did I actually did a few work back in Microsoft when I was an intern there, and on this synonym discovery by using the search log, query log, actually. I think for that, it's in academia, it's still ongoing problem. I feel like the using only the text signal to solve this problem might be too hard. By that I mean like just looking at the surrounding context of the sentence and trying to decide if one phrase is the synonym of the other phrase or vice versa might be too hard because the language by itself is too ambiguous. So I feel like this might be easier to be solved with user engagement signals or feedbacks, things like that. So to that, I mean, like maybe we in academia, we are not even leading the game in solving these problems because lack of this type of user feedback data. Yeah.
I see. Okay. Yeah, using engagement data is actually like a good practice. I think Pinterest is also leveraging, and then a lot of search engines are also leveraging.
Right.
Awesome. Oh, thanks, John. All right, I think it's time to move on to the next presentation. Before that, I'd like to introduce Vijay. Vijay Mohan is our architect